Thank you. Thanks everyone for joining in. My name is Vivek. I'm the VP of Product at Indusface. And in today's webinar, we'll be covering the importance of virtual patching and how it can help you protect against critical attacks, right? So that your applications are not hacked. We will also talk about real life scenarios, how virtual patching actually helps. With that, let's get started. Before going to the crux of the presentation, let me give you a quick introduction about Indusface. Indusface is a cybersecurity startup. We are in the business of protecting web applications and APIs. We have customers all across the world, and these are some of the customers whom we are protecting. Indusface is also named as the customer choice in Gartner's Voice of Customer report, right, for the web application and API protection. We are also the only vendor who has got 100% recommendation rating for 3 years in 3 consecutive years. So that means the customers who are using our product have recommended and said that we like the product that they are and the services that they are receiving, and they are happy to recommend it to other customers also. With that, let's get into the crux of today's webinar. Before I talk about the importance of virtual patching and how virtual patching can help you, let me set some context, right? Why virtual patching is needed, right? So let's talk about it for first few minutes, and then we'll talk about how virtual patching is important. So in today's day and age, what we see is more and more organizations are adopting Agile methodologies, right? So we see rapid development and rapid deployment as a key factor for any organization's success. I have seen many organizations which have taken or adopted continuous development to such an extent that they make releases every day. So they make updates, they make new features, there are infrastructure updates that they happen, all this to ensure that the product catches up with the business and they grow faster, right? And in the quest of rapid development, more and more third-party tools are also being used as part of the application, and more open source components are also being used. One of the recent studies suggests that more than 96% of proprietary applications have open source code in it, and they use approximately about 256 components of open source in a proprietary software, right? So that's the extent of third-party integration in proprietary applications. So what does these things mean when it comes to security, right? What happens is in the quest of rapid development and deployment, security takes a backseat, right? Bad programming practices creeps in, lack of hygiene. There could be issues because of third-party components that is being integrated. We see more and more open source components being used, as I said, and these open source components could have vulnerabilities in it or security holes in it, which as an organization or as the development team, they have no control over it. And because of all these rapid developments, what we are also seeing is rapid growth of what we call a zero-day vulnerabilities. So zero-day vulnerabilities are vulnerabilities which are found in code platforms that is already live, right? So essentially what it means is there is actually 0 day to fix it because the vulnerability is already live and hackers could exploit it, right? So that's the extent, and we are seeing rapid adoption. Lot of 0 day vulnerabilities which are found in production environments. So on average, based on our study and based on applications that we are scanning, we see about 15 vulnerabilities are found in each application, and about 20 to 30% of them are critical vulnerabilities. So these are vulnerabilities that are there for hackers to exploit, and if exploited, it could cause serious concerns. One of the recent study also says that nearly 80% of the breaches that happen because of exploit of the 0 day vulnerabilities. Right. So this is what is the how where as an industry we stand. Right. Uh, Industry is focusing over rapid deployments, and because of rapid deployment, security is taking a backseat, and there is more and more critical vulnerabilities found in production. Right. So how does organizations react to it? Right. So one of the things that all organizations try to do is to get visibility on the risk posture, right? So most of these organizations have matured processes in place to identify vulnerabilities uh, early on, right? So there are various tools that are being used at various stages of the development cycle. SaaS tools are used during the development to identify vulnerabilities at code levels. Then there are dynamic application security testing, which is more towards identifying vulnerabilities at runtime. So it kind of mimics what an hacker does and then tries to say, hey, these are the vulnerabilities that are found at runtime. And also, all these are also complemented by pen testing, where manual ethical hackers probe the applications and do ethical hacking to say, hey, these are the vulnerabilities that are available in the application. So, using all these methodologies, generally organizations get a fair enough idea of the vulnerabilities that are there, right? But the challenge is what happens after that. So, if you see, once the vulnerabilities is identified, what needs to be done is it needs to be fixed, obviously. But to fix it, what happens is you need to identify first, the security team has to identify which team is responsible for this part of the code where the vulnerability is, then get the business team involved, get the stakeholders involved, um, push them and give them the criticality of these vulnerabilities, ensure that these vulnerabilities and the patches for these vulnerabilities are prioritized, then it goes to the release cycles, and then it finally gets released. In the meantime, the business team is pushing for, again, because of the rapid deployment cultures, they are pushing for more features to grow, to be out, because growth is a priority. And it always remains a tug of war, right? And what eventually happens because of the tug of war is obvious, is very obvious, right? Before we go to the next section of the webinar, we have a poll question. We would like to see what is the situation in your organization. If a critical or high vulnerabilities are found, how long does it take for you to fix those? Please vote for the polls that is live now. I'll give you a minute and then we get started. We'll be closing the poll shortly. Please close the poll. Can you share the results, please? Okay. Oh, many of you have said it gets patched in 30 to 90 days. That's good to hear. And some of them have said 90 to 180 days, and few have said they do not have an idea. It's good to hear what is happening in the organizations, to the organizations who are able to fix it within 30 to 90 days. Congratulations, you are ahead of the curve, right? What we see in our industry and across all our customers, we scan about few thousands of sites. And how long does it take to patch? It takes to patch about 180 plus days to patch these critical and high vulnerabilities. That means from the time the vulnerability is first reported to the time it is closed, it takes on an average 180 plus days. And this is what we are seeing in our applications, and this is what the industry is also saying, right? Some of the researchers we have added into the slides. This is what the industry is also saying. And the reason is kind of obvious, right? Because it has to go through the cycles, and it has to be prioritized across all the other business things, and security generally or can take a backseat. So what is the repercussion of this? The repercussion of this is actually you're giving gift to the hackers, right? These vulnerabilities are nothing but gifts to them. And how does a hacker generally go about his job? He probes the applications, sees what is the weakest link, what is the vulnerabilities there, and they exploit it. If a critical and high vulnerabilities are open in a live production environment for more than 180 days, for 180 days, you are taking a risk that hacker can anytime come and exploit it, right? So that's the risk that all organizations are taking, and that is why hackers are benefiting. So, and all these things lead to critical hacks and critical data is getting leaked, right? These are some of the examples that we have seen, and as we were researching, we wanted to give you some examples of how a vulnerability which is out there can be exploited. One of the common vulnerabilities that can be exploited is broken access control. So this is about your access control is not properly put in place. There are vulnerabilities because of that, which when exploited leads to things, right? Snapchat is one of those examples where this is a nice example where actually a security team had actually done their analysis and reported it to Snapchat, saying that, hey, there's a vulnerability which could be exploited. But Snapchat team came back and said that, hey, these are theoretical attacks. This is not really practical in live scenario or real life scenario, right? So somebody went ahead and exploited the same vulnerability after some time, resulting in about millions of usernames and passwords being exposed. Facebook similarly faced a broken access control vulnerability where hacker could get access as an admin of a web page. So they could get access to a web page and then actually restrict access to the real admins. So imagine this happening to a company's Facebook page, right? It's a huge concern. You guys would have heard about Panama Papers leak, where a lot of illegal activities were reported for major players in the world. But this was again an vulnerability exploit at the crux of it, right? The law firm in Panama were using outdated software, and some hacker had exploited that, and then an SQL injection to get these records and leak it. Another common example that comes to mind is security misconfigurations. More and more people are adopting public clouds, using storages like S3 storage and other things. And because of bad configurations, using default configuration and the likes, unwanted access is provided to people where sensitive data get leaked, right? So these are real life scenarios where vulnerabilities have been exploited and has caused real pain to organizations and their customers. And this can happen to anyone as if there is no proper process in place to ensure that these vulnerabilities are protected in time. Our founder, Venkatesh, runs a podcast, and in one of the podcasts, he was talking to Sunil, the CISO of Glean. Glean is an enterprise search engine solution which is backed by AI. And he was talking about securities, and he was telling him that it takes, according to us, it takes more than 200 days to patch the vulnerabilities, and this is what he had to say.
And the numbers that you quoted, I kind of completely buy into that. And the complexity is both, your first-party application and the third-party application. So even for the first-party application, having the software bill of material, an SBOM, as to all the places where you are using the vulnerable version of Log4j. And are you using the vulnerable constructs of the Log4j? That's a very easy question to ask, very difficult to answer. Correct? Yeah. Because first of all, you don't even have an SBOM. Correct? So how do you go about doing that? That's one aspect. And then the third party product or the software that you happen to use within your stack, finding out that dependency tree, whether they are using one of the vulnerable constructs, is also a fairly uphill task. Once you have that visibility, then you talk about the second set of challenge. Now, who is the owner of that application within your company? So that you can get it into part of their sprint cycle that this needs to be fixed by this timeline. Because then that's an internal organizational challenge, and there's no clear mapping of application to the team. If it's a monolith, it's even harder. If they're microservices and you have good attribution, but very few companies have reached that set of maturity. Most of them, don't have it. And hence I can completely buy into it taking 200 plus days. And hence virtual patching, because you cannot wait for those 200 plus days for the vulnerability to be sitting out there. So what do? You apply a virtual patch in your WAF so that at least you have applied a patch, you stop being vulnerable, you stop the bleeding, and then you have your time to fix the core issue.
So that's it. Sometimes it's good to hear from the horse's mouth, right? The CISOs talking about their pain points and why they think it takes time to fix these vulnerabilities. And obviously, Sunil talked about how to solve for it through virtual patching, which is what we will be talking through the rest of the session. Yeah. Before we go to the next part of it, there's another poll question. I talked about why we think it takes time for vulnerabilities to be patched. Sunil talked about his experience. We'd like to hear from you. So poll has started. Please provide your view on why you think vulnerabilities take time to patch. We'll be closing the poll shortly. Thank you. The poll is closed. Can you share the results? Great. Prioritization of features over patching. Too many vulnerabilities to manage with poor tracking and mapping. Missing clarity on the ownership and assignment. See, all these are valid. Various organizations have various reasons, but one of the major reasons that we hear are these things, right? And I think the priority order is also right. About half of the people have a problem with a lot of vulnerabilities and which needs to be prioritized. Many have a problem of balancing between features and security things, and some are in bigger organizations. There are more bigger problems on trying to find who the owner is at the first place, right? So there are different problems for different organizations, and all are valid. So how do you solve for this, right? And what is it that as a security team they can do for these things? So the solution, one of the solutions, and what we think is one of the easier solutions that many of the security teams can employ is virtual patching. So what is virtual patching, right? In a scenario where there is no WAF in place, what happens is there's an application. The application has some vulnerabilities. Now it is exposed over internet. Hacker comes in, probes this application, finds any vulnerability, and exploits it, and data gets breached. This is a scenario without WAF and virtual patching in place. Now, with WAF in place, what happens? WAF comes in line to the traffic from internet to your application, right? So all the traffic over the internet comes through WAF, WAF inspects it, and sends the traffic back to your application. So now when a hacker probes, right, when he tries to probe for a vulnerability, that traffic goes through WAF. Now the WAF knows that he is probing for a vulnerability, and he knows that he's trying to exploit the vulnerability. So this WAF would be based on the behavior of the hackers and the hacker trying to exploit the vulnerability. it will block those requests, right? So that there is no chance for hacker to go to the application and exploit a vulnerability in a real life scenario. And this is what we call it as virtual patching, right? So essentially, well, as the name suggests, right, instead of when you patch it in the code, it is patching. When you virtually patch it in WAF, and though the vulnerability still remains in application, you virtually patch it in WAF. So that's why we call it virtual patching. So how does this actually play out in a real life scenario, right? So let's take an example, right? This is one of the vulnerabilities that was found in in last year, right? And it's a vulnerability that was found in Spring Framework. Spring Framework is a widely used framework for Java applications, which is used for MVC controllers, where it helps in memory management and configuration management, right? So it's a widely used framework in all the Java applications. And an RCE vulnerability was found in this framework. RCE is a remote code execution vulnerability, which essentially means hacker exploiting this vulnerability can push in some code snippets into the server and make it executed from a remote, right? So hacker sitting in a remote location could inject a code snippet and make it run in the server, which eventually mean he could push in a malware, he could push in a remote code, which executes and then gives him permissions for the entire server, and then he can go and do a lot of things. That's why remote code executions are generally very critical, and any remote code execution vulnerability should be treated at a high severity. So now, it was a 0-day vulnerability, right? And when this vulnerability was reported, a patch was made available. But again, the solution which was recommended was, hey, please upgrade the patch. But now we have discussed what is the challenges in getting that going, right? Okay, now this vulnerability is found, you have to get it upgraded, but updating a version or framework is not that easy, right? Depending on which stage of the organization, and they might be using an older version of it, or getting it has to go through a sanity test. It goes through all the problems that we talked about in the previous session. So what next? What other can be done? What can be done is a virtual patch can be created in WAF. And how was a virtual patch created? See, the attack was essentially exploiting the vulnerability where there are class objects and there are various parameters of these class objects. And hacker was using the vulnerability to get access to these parameters, which they should not have access to, and then use that for RC. Right. And the way they were getting this access to was using this class module close loader function call. So one of the things that our security team said was, hey, this is not a function call which will be commonly used from a remote location, right? It should be a local function calls, and it should not be. There are very little reasons to make it call over the internet. So if the payload has this class module class loader function in it, then block that request. So which eventually means that if any hacker tries to exploit this vulnerability, he would be immediately caught and the request will never reach the application. And so the exploit of those vulnerabilities would be avoided, right? There could be certain cases where for some reasons, this code has to be called. But again, that would be a very specific reason. It would be from some remote server. So you could just whitelist for those IPs, but block for common request that is coming in with this function. So an exception can be made based on the application's need. And this is what we call as virtual patching and doing a surgically accurate rule based on the application's need. It is not just blindly saying that, hey, just because this function is there, block it, right? It is also like looking at the context where it should be called and where it should be, for which request it should be blocked for, and also having the ability to create this exceptions based on the application need. And the unique proposition that we bring to the table is that we create these virtual patches for our customers. So we don't expect customers to have these security expertise. So they can just request for these custom rules from the portal, and then our team would write these rules within allotted SLAs. Generally, for such critical vulnerabilities, it is 24 hours, and then high vulnerabilities 48 hours. So eventually, what happens is a vulnerability, when found, generally in average, when it takes more than 180 days. In this case, because WAF was there and we were there to create those surgically accurate custom rules, the vulnerability was patched for our customers within a day or two, right? Mostly in a day, because this was a critical vulnerability. So we ensured that all our customers who are using these frameworks were immediately patched. So within a day, from the time the zero-day vulnerability was reported, all our customers were protected, right? So now the customers have the leg room. They can go and work, the security team can go and work with the application team, try and get it prioritized and have it fixed in the application. We are not saying that virtual patching is a replacement of getting it patched in the code. There's always a best practice and a good hygiene to have it fixed in the code. But virtual patching gives you that room to get it done using your own process, meanwhile not compromising your security. So that's the benefit of virtual patching. The other benefit, that's more on how the WAF is being built and from our end, is that these virtual patches also gives you the insight, right, of the hacker. So in this case, because the hacker was trying to do an exploit of using this payload, and we know that the payload is generally used for hacking intent, I know now the intent of the user. So based on that, even if he does other actions around the same time, we know that this user has an hacker intent. So our security profile for that user would have increased, and we would have blocked the entire user completely, right? So that's more around the behavioral and anomaly detections that we have in WAF. But virtual patches lend as a key input for those behavioral analysis and everything also. But that's more of a side effect. The major value add that we provide is that the vulnerability, which generally would have taken 180 days to be protected, is protected within a day, right? That's the power of virtual patching. Hope that provides you a good insight of why virtual patching is important and how virtual patching should be used in real life scenarios. So we have this and more in our apptrana solution. So apptrana is our web application and API protection solution. And as I said, our unique proposition is that we provide a complete managed solution, right? So instead of asking customers to create these security rules by themselves, which is very hard to do, and customers do not have the security expertise, our team writes the rules for you. So we are not expecting customers to have any security expertise. So, and we also combine our solution with a risk-based approach. So what we mean by it is we identify the vulnerabilities. We have our own task scanner, and we complement it with pen testing also. So we tell you what are the vulnerabilities that are there in runtime. And then we also say, hey, these are the vulnerabilities, and these are the vulnerabilities which are patched in real time in WAF, right, by a default rules. And by the way, as you onboard into our platform, the default rules are again monitored for false positives, and we remove false positives for our customers. So ensure that there are no false positives. So, and in our portal, you see a clear view into, hey, these are the vulnerabilities. These are the vulnerabilities that are patched by our default rule sets. These are the vulnerabilities that needs custom rules. And you can just click that, hey, requesting for custom rules, and our team will write the rules for you and ensure that it is patched within the given SLA. So that's the power that we provide to our customers. And we ensure that our customers' protection are up to date. They don't have false positives. And one more thing is that 99% of our applications that is onboarded behind WAF remains in block mode, right? Which is generally a challenge in real life, right? So that's where we are, and that's our solution. And we also complement it with CDN. for website acceleration. So that's pretty much where we are coming to the end of the webinar. Final poll questions. Did you like the presentation, and would you like to see a demo of virtual patching in action, right? So that our team can reach out to you and give you a demo as needed. So again, a poll has started. Again, poll will be closing soon. Thank you. We'll close the poll. Thank you. Thanks for your submission. Now we come to the end of the presentation. Happy to answer any questions. If you have any questions on this, please feel free to ask. I'll be here for the next 5-10 minutes to answer these. Okay, I see there is already one question. Do you have a recommendation for the best practices to mitigate a zero-day threat or a vulnerability? As I said, right? I mean, the recommendation is to have a WAF and get a WAF solutions which will help you protect against these vulnerabilities, right? Instead of giving a WAF and giving you a portal where you can go and write the rules. Generally, you won't have the security expertise to do that. So find a solution which can provide you that security expertise, where they would write the rules for you instead of asking you to write your rules by yourself. At least that would be my recommendation, because there's no way for anyone to avoid zero-day vulnerabilities. And as I said, because many of the solutions or proprietary codes also now have open source components in it and all those things. Today you might be all good. Tomorrow you might have a critical vulnerability which you don't know about, right? So things keep changing. You have no control, or you cannot avoid your application having a zero-day vulnerability, but you can have processes and solutions in place which will help you mitigate it fast. I hope that answered your question. If there are any other questions. You can also, mic is now open, so you can unmute yourself and ask questions also if you're interested. Okay, looks like there are no more questions.
Vivek, Santosh here.
Yeah, Santosh.
So, when we go with so many solutions to the customers, even customers are confused. So, and at the same time, I just want to say, everyone talks about the enterprise customers, but enterprise customers, Indian enterprise customers, domestic enterprise customers is, I don't know, most of them are not there, or else they are there in the northern part. If you look at the IT ATS from global, they are from outside India, they already come with all these details. So left out to us was the SMB and the mid-market between 250 to 1,000 users. Now, these users also become critical. In this case, I just want to say, what is the story we can take it to the customer and pitch in over there?
No, the story is what I had projected, right? There are vulnerabilities that, I mean, you can't avoid applications being live without any vulnerabilities, right? No matter what processes you put in place, it is bound to happen that there are applications that any customers own which will have vulnerabilities in it, right? Now, how do you put in a process to mitigate those vulnerabilities? Getting it patched will take more than 180 days, depending on the organizations and what is the process they have. So the best solution that they have is to get it protected through virtual patching. And solution like apptrana would provide you virtual patching, where we do the heavy lifting for the customer. We write the rules surgically accurate for the customer's need instead of customer writing it themselves. So that's the value proposition that we provide, and that's what should be taken to the market.
So when you say virtual patching across all this thing, what all virtual patching you will take care of? Only on the security front, on the non-security front?
Only on the security front, right? We are a web solution, and for vulnerabilities that is found in the application, we will provide virtual patching through our web.
Okay. Thanks, Vivek.
Thank you. Pleasure. Any other questions? Okay, then I think I'll give you back your 15 minutes. It was a pleasure talking to all of you, and I hope you found this a bit useful. If you have any further questions, you can drop me a note, reach out to our team, our website, and we'll address those. Oh, I see there is one more question. How to identify false positive vulnerabilities when we scan web application? Again, false positive is a common problem when it comes to web application scanning. And the reality of the situation is no scanner is perfect, right? Including us. There's no way to completely eliminate false positive from the vulnerabilities that is reported. But what can be done is provide a better solution, right? That's what we provide, where we provide what we call as proof of concept, where we give you a proof on saying that, hey, why this vulnerability was reported, why it is, right? So if there was a SQL injection possible, then we'll give you a possible screenshot of, hey, this is what payload we sent, and then this was a SQL injection that was possible. So that is what we call as proof of concept, where customers can request for proofs for vulnerabilities that they are not sure about, that it could be potential FPs, and we will manually verify it and give you a proof for that. This way, the security teams can go through the reports wherever they are not sure, request for POCs, get a proof that the vulnerability exists, remove all the FPs with the help of our managed service team, and then present the clean report to the application team to get it fixed. That's how we go about our job of avoiding false positives in scanner. Great, I'm happy to see interesting questions. If there are one more. Okay. Which tool you recommend? Obviously, I'm going to recommend my tool. Indusface has a DAS scanner. It is called Indusface WAS, Web Application and Scanning. We have a free trial for 14 days, and it's also have a free forever plan also to it. So I recommend starting with that, see if you find the solution useful, and then explore other solutions. Great. Yeah. Okay. Abhay, is there a question?
Yes. Good afternoon. Actually, can I have some comparison or some better card regarding that your WF means Indusface WF and F5 WF and Cloudflare. Actually, we are evaluating. We are planning to have something. So can I have like comparison sheet?
Sure. We have a comparison sheet. I don't think I can explain to you all the comparisons over the webinar, but we will share you the sheet, right? We have. I think I'll pass on your contacts to our team, and then they will reach out to you provide you more inputs around what we do, and also will share the comparison on.
Okay. Thank you.
Perfect. Pleasure. Anyone else? Okay, then. Thank you. Thanks for sticking in till the end of the presentation. Share it's there on the screen, vivek.gopalan@indusface.com. Vineet. That's my email ID. Again, thank you. Thanks a lot. It's a pleasure.